Well, here's a problem involving electric circuits and Ohm's law, which is that the voltage is the current in amperes times the resistance, and that voltage is slowly dropping as a battery wears out, and maybe it's causing a fire on a Boeing 787, but I'm not sure about that. So at the same time, the resistance is increasing as the resistor heats up. So use the equation, and here it is, and this would be like partial derivative of this equation. dV dt equals the partial of v with respect to I times di dt plus the partial of v with respect to r times dr dt, keeping in mind that I and r are considered functions of time, because after all the resistance is changing and the voltage is changing, so we do have this relationship from what we know about, how far back do we have to go here? Well, what we know about partial derivatives describing a situation like this. So here's exactly what we have. So bear with me. So to find out how the current is changing at the instant when the resistance is 600 ohms, the current is 4 amperes. The change in resistance with respect to time is half an ohm. See, it's becoming more resistant as it heats up. That's positive. And the change in the voltage is negative 0.1 as the battery wears out. So we can fill in a few details. This one goes in for dV dt. We don't have much for these two, but we do have the change in the resistance as given as 0.5. And so it looks like we need more information to try to find out how the current is changing. I guess that would be di dt. But we do have some information more, and that is the fact that the partial of v with respect to I equals r. That's from this equation. And the partial of v with respect to r is I. Well, that's good. Now, what does that mean for us? That means that the partial of v with respect to I is r. That's 600. So we can now fill in 600 here where we had the partial of v with respect to I. The partial of v with respect to r equals I, and that was given as 4/100ths of an ampere. So there, that is easily filled in. And now we have an equation with only one variable in it, and that's the change in the current with respect to time, and that's what we're supposed to be finding, how the current is changing at the instant when r is 600, I is 4/100ths of an ampere, dr dt is half an ohm, and the change in the voltage is negative 0.1. So solving this for di dt is not very hard. You could multiply this out and subtract that 0.2 from both sides of the equation. Is that what that is? 0.02, sorry, from both sides of the equation. So then we have negative 0.03 here, and then divide both sides by 600. And if you do the arithmetic on that, the change in the current at that instant is negative, so it's getting less current. 500 thousandths of an ampere per, I forget what the it would be per second, because these were given in I should have said per second there, right? So there we go. That would be 500 thousandths of an ampere per second. All right. So that's our problem involving ohm.